Okay, hi. So this is take 25. So today I'm going to be talking about the endocrine system. The endocrine system is basically a system comprised of glands that's located all throughout the body, and they communicate by sending chemical messengers in the blood, also known as hormones. These hormones, when sent out into the bloodstream, are used to target specific parts of the body to create changes. These changes are necessary for us to maintain homeostasis. Homeostasis is just a fancy word for us keeping all of our internal levels at optimal level. Okay, so first I'm going to start with the pituitary gland. The pituitary gland is located in your brain, and it sends messages to pretty much every other gland in the system. It's often called the master gland. Can't remember if I said that already or not, but master gland. And one example of this is how it produces TSH. So TSH is a thyroid stimulating hormone. This hormone causes the thyroid to produce T3, which is triiodothyronine, and T4, which is thyroxine. And together, these two chemicals can affect your metabolism, your body temperature, and your energy levels. I have hypothyroidism, so I have to take medicine to correct this because I often get very tired. I have a really hard time maintaining my weight, even with my medicine, which is levothyroxine, T4. So the thyroid gland, which is located in your neck. God, I can't remember if I said that yet or not either. Okay. It's located in your neck, creates T3 and T4. Okay. The reason that my doctors knew that I had hypothyroidism is because I have too much TSH in my blood. What this means is that my pituitary gland realizes that I need more T3 and T4 in my system, but my thyroid's just not doing it. So it's producing all the TSH it can, but my thyroid's just very underactive. It's not doing anything. So there's that. Next, we have the pancreas. The pancreas is huge when it comes to blood sugar. So basically, the pancreas has alpha cells, which make glucagon, and beta cells that make insulin. Now, whenever your blood sugar drops, glucagon tells your liver to release glucose. Oh, Lord. This raises your levels back up. Whenever your blood sugar level gets too high, then your pancreas, the beta cells, release insulin. The insulin travels through your body, and as it does this, it uses the GLUT4 transporter, and this transporter inserts itself into the membrane lining of fat and muscle tissues. And when the insulin comes through the blood system, the glucose inserts itself into cells. Once it leaves your blood system, this brings your levels back to normal. And then any excess is then stored in the liver as glycogen. Next, we have the adrenal glands. They're located on top of the kidney, and they are in charge of producing cortisol, which helps with stress, but they're also in charge of producing adrenaline, which is interesting because adrenaline running through your system, which I'm sure you know, in fight or flight situation is crucial, and it's very fast acting, which is not like the endocrine system. Usually it's slow. So next we have the parathyroid glands, and they're in charge of producing the parathyroid hormone, or PTH. This hormone helps with calcium levels. If calcium levels drop, then the presence of this hormone in your bloodstream causes your body to pull calcium from bones and ups calcium absorption from foods. Next, we have the pineal gland. It's also located in the brain, and it's in charge of melatonin. This controls your sleep-wake cycles. Interesting fact, kids with ADHD actually don't make enough of this, which I also have, and I didn't make enough of it as a kid. I can sleep through anything nowadays. So now we have the hypothalamus. So this gland, the hypothalamus, works very closely with the pituitary gland, and it's kind of like the link between the nervous system and the endocrine system. And next I'm going to talk about the thymus gland. So the thymus gland is most active during childhood. What this gland does is it produces thymolin and thymolin. Oh, I'm sorry, I could never say those. Anyway, they're in charge of developing T cells, which are specialized white blood cells, or T lymphocytes, and they are like the knights of the white blood cell system, which is your immune system. Finally, we have the reproductive glands. So ovaries for females, testes for males. Ovaries produce estrogen and progesterone. Estrogen helps stimulate the growth of the endometrium, which is the lining of the uterus. Progesterone helps prep it for implantation and the length of the pregnancy. Now, testes produce testosterone. This helps stimulate the growth of the male reproductive system. Secondary sexual characteristics, bone mass, muscle mass. Bone density and muscle mass. And I'm pretty sure that covers all of the glands. Yes, got all the glands. Okay, so now, as I mentioned earlier, negative and positive feedback is how the endocrine system runs. So negative feedback is much more common than positive. Negative feedback is kind of like your body's stop signal. So like when things get too high, hey, stop producing that, let's bring it back down. When it gets too low, hey, stop, we need to stop producing this and produce more of this. So an example of this is insulin and your blood sugar levels. If your blood sugar level gets too high, negative feedback, hey, beta cells in the pancreas, we need to make insulin to bring this sugar level back down. And it stays about right here, fluctuating constantly. Positive feedback is less common. It's more like an amplified response, kind of like when you talk into a microphone and your voice comes out amplified until it reaches a certain goal. So an example of this is labor. So when your cervix stretches, you have stretch cells in your cervix. When these cells start to stretch, it sends a signal to the posterior pituitary gland, which releases oxytocin. This oxytocin causes contractions to get stronger and stronger and stronger and stronger until the baby comes. Then it stops. This is positive feedback. So, in short, this is the endocrine system, and I hope that you learned something from it. And thank you for listening.